Dear children, in this session we are going to discuss about inverse trigonometric functions, the second chapter in our textbook. In class 11, we have studied trigonometric functions, graphs of trigonometric functions, identities of trigonometric functions, and solutions of trigonometric equations. Now, we are going to discuss inverse of trigonometric functions. When a function is said to be invertible, a function f from R to R or any set A to B is invertible if and only if it is a bijection. So that point should be in our mind before going to inverse trigonometric functions. Now let us start with the inverse of sine function. Consider the sine function f defined by f from R to close interval minus 1, 1 given by f of x is equal to sine x. We have to find the inverse of this f of x is equal to sine x. Let us take the graph of sine x. You can see here, my question is that whether the sine function is a bijection. See, this is the graph of a sine function. Okay? The range of sine function is minus 1 to plus 1. Sine function oscillates between minus 1 and plus 1. Whether the function is bijection is 1, 1 and on 2. Of course, it is on 2 because all values between minus 1 and 1 are taking the function. That is, the range set is minus 1 and plus 1. It's clear. So, it is on 2. Whether it is 1, 1, let us check. See, here, for this particular value of x, there are this value, this point and this point. On all these points, the line is cutting the graph of sine x at different points. So, if it is a point x1 and this is x2 and this is x3 and here x4, and for all these values, f of x, that is sine x, is taking the same value. So, it is not 1, 1, it is a many one function. You can see that. So, you can see that the line in all these cases. So, f of x is taking different values. So, function is a many one function. So, it is not invertible. A function f is said to be invertible if it is 1, 1 and on 2. Clearly, it is on 2, it is not a 1. Now, we have to find the inverse also. What I am going to do is, I am going to restrict the domain in such a way that the function is 1, 1 and on 2. See, if I am taking the domain as, here it is minus pi by 2 and plus pi by 2 here. If I am taking the domain as between minus pi by 2 and plus pi by 2, you will get the value between minus 1 and plus 1. So, if you restrict the domain to minus pi by 2 to plus pi by 2, close interval, minus pi by 2 plus pi by 2, the function will be bijection 1, 1 and on 2. Otherwise, if you restrict the domain to pi by 2 to 3 pi by 2, that case also the function takes values between minus 1 and plus 1. So, again it is 1, 1 and on 2. If you are taking 3 pi by 2 to 5 pi by 2, in that branch also the function is a bijection. So, if you restrict the domain in such a way that the function f is 1, 1 and it is, of course, it is onto, but 1, 1, then the function become an invertible, that sine f of x equal to sine x is invertible. So what we are doing here, we are restricting the domain to this case. Now at present you can see that here in this branch the function is a 1 1 and on 2, so hence it is invertible. Not only in this branch, suppose I am taking this case in here. So here it will become minus 3 pi by 2 to pi by 2. Here also the function is 1 1 and on 2. Now we are taking the next branch. In here also the function is 1 1 and on 2. In this branch that is a pi by 2 to 3 pi by 2. And if you take in this branch also that is 3 pi by 2 5 pi by 2, also the function is 1 1 and 2 and so on. In all these branches the function is a 1 1 and on 2. Is it clear? That is, from the graph it is clear that f of x is equal to sin x is many one on 2, hence not invertible. If we restrict the domain R into any one of the interval minus 3 pi by 2, minus pi by 2, or minus pi by 2, pi by 2, or pi by 2, 3 pi by 2, or etc., the function become a bijection, hence invertible. Is it clear? Now, not necessary to see graph of sine function once again. Now, we denote the sine inverse of sine by sine inverse. And another word of sine inverse is arc sine. Sine inverse or arc sine. Thus, sine inverse is a function whose domain is minus 1 plus 1. And the range could be any of the subintervals minus 3 pi by 2, minus pi by 2, or minus pi by 2, pi by 2, or pi by 2, 3 pi by 2, and so on. Corresponding to each such interval, we get the branch of the function sine inverse. The branch with the range minus pi by 2 to pi by 2 is called the principal value branch. It is called the principal value branch. The principal value branch. In this interval, minus pi by 2, closed interval minus pi by 2, pi by 2, that branch is called the principal value branch, whereas the other intervals as range give different branch of sine inverse. Is it clear? Now we are going to define sine inverse. The sine inverse is from minus 1 plus 1 to minus pi by 2 to pi by 2, defined by y is equal to sine inverse x implies and implied by sine y is equal to x, where y element of minus pi by 2 pi by 2. To avoid that gap between the f of x, sin x and sine inverse, I am connecting this to the function and its inverse. Relations and functions inverse. You can see here. Now, what about a sine function? Sine function, actually it is from R to R. Now we have restricted the domain to minus pi by 2 plus pi by 2. So it is minus pi by 2 plus pi by 2 to close interval minus 1. Let us connect this with the function. Suppose f of x, f is a function, f of x is defined from a to b. Then f inverse is defined from b to b. And if f of x is equal to y, we write f inverse of y is equal to x. The same thing is for here sine function also. So sine is from minus pi by 2 to minus 1. plus 1, close interval minus 1 plus 1. So it's inverse. If f is the function, f inverse. So sine is the function here, sine function. So sine inverse. So what about sine inverse? Sine inverse should be from word to word minus 1 plus 1 to minus pi by 2. So minus 1 plus 1, the domain is minus 1 plus 1 and the range become minus pi by 2 pi plus pi by 2. Now, f of x is equal to y implies f inverse y is equal to x. So, sine y is equal to x implies what you will get? Sine inverse x is equal to y. Now, continuing, the domain of sine inverse is minus 1 plus 1 and its range is minus pi by 2 plus pi by 2. Now, f composition f inverse or f of f inverse of x is equal to x. Same way, sine of sine inverse of x is equal to x, where x is in the domain minus 1 plus 1, domain of sine inverse. Same way, f inverse of f of x will be equal to x. So, sine inverse of sine y is equal to y, where y element of minus pi by 2 plus pi by 2. These are the three important points. Now, what about the graph of sine inverse? Graph of arc sine inverse. Graph of sine inverse. Let us see the graph of sine inverse. In the GeoGebra we can see. See, this is the graph of sine inverse. Let me zoom it. So this is the graph of sine inverse. So you can see that in the case of a sine, the x-axis pi by 2, minus pi by 2, etc. it is the marked. But in the sine inverse, it will be in the y-axis. So x-axis become y-axis and y-axis become x-axis in the case of sine inverse. So here it become minus pi by 2 and here pi by 2. So the graph is, this is the graph of a sine inverse. Actually, what is the graph of sine? This is the graph of sine. This is a graph of sine. But I told you that this graph is in the principal value branch. So the sine inverse can be defined in the remaining branches also. That is from pi by 2 to 3 pi by 2 or 3 pi by 2 to 5 pi by 2. So sine inverse range can be marked as pi by 2 to 3 pi by 2 or 3 pi by 2 5 pi by 2 or minus 3 pi by 2 minus pi by 2 etc. If it is so, what will be the graph? If you join that graph, what will be that? See, if the range is considered as pi by 2 to 3 pi by 2, it is pi by 2 and 3 pi by 2 here. So it becomes in this way. If it is taken minus 3 pi by 2 minus pi by 2, so the graph will be coming in this way. So what will be that graph? That graph will be, this will be the graph. This will be the graph if we joined all these branches. The graphs of sine inverse in all these different branches. Okay, this red color graph is the graph of sine inverse in the principal value branch. I think it is clear now. So that is, we have discussed sine inverse and the graph of sine inverse. Now graph of sine inverse and graph of sine, there is a relation. It is the mirror image about the line y is equal to x. Let us see. So in the GeoGebra you can see the graph of sine inverse. Sorry, sine. This is the graph of sine. This is the graph of sine. And this is the line, this line is the line y is equal to x. Okay? I am taking a point A in the graph of sine x. This is the graph of sine. I am taking the reflected image, reflection of A with respect to the line. The reflection of A with respect to line y is equal to x is a dash. Now if we move this A dash also will move because it is a reflection. Let me see what will happen here. Now you can see that the point A is moving, so we get the point A dash also. See that. So this is the graph of a sine inverse. This is the graph of sine inverse, and this is the graph of sine. This is the line y is equal to x. Now it is clear that graph of sine inverse is the mirror image or reflection of graph of sine with respect to the line y is equal to x. Now it is clear. The same picture is in our textbook. Now let us define the inverse of cosine function. The same way, let us we know that the cosine function, the domain is R and range also -1 plus 1, because cosine function also oscillates between -1 and +1. So consider the cosine function f defined by f from R to -1 plus 1 given by f of x is equal to cos x. My question is that whether the cosine function f of x is equal to cos x in this domain and the range is invertible. Let us see. Let us take the graph of y equal to cos x. This is a graph of y is equal to cos x, where a domain is a set of real numbers and range is -1 to +1. Range is -1 to +1. Clearly, the function is not 1 1 because it's onto, because between -1 and +1, all the values of the graph has taken the values between -1 and +1, so it is onto, but it is not 1 1. We can check it as whether it is 1 1 or not. So if I am drawing a line here parallel to x-axis, the line intersects the graphs at different points, so it is a minimum function. So at present the function y is equal to cos x is minimum onto. We have to make it as 1 1 onto, then only the function is invertible. How to make this 1 1 and onto? Just like in the sine inverse, we have defined the sine inverse case. The same way we have to restrict the domain. How to restrict the domain? Let us see. This is the case. Now the cosine function takes values between -1 and +1. If you restrict the domain, actually the domain is set of all real numbers. If you restrict the domain from 0 to pi, if you restrict the domain from 0 to pi, the cosine function takes values from -1 to +1. So in that restricted interval, subinterval, the cosine function by f of x is equal to cos x is 1 1 as well as onto, hence inverted. Otherwise, if you restrict the domain to pi to 2 pi, then also the function is 1 1 and onto, hence invertible. If you restrict it 2 pi to 3 pi, then also it is 1 1 and onto. Or in the same case in the negative branches, -pi to 0, the function is 1 1 and onto. So in all these branches, the function f of x is equal to cos x is a bijection, hence invertible. I will show you the branches, restricted branches. This is the one of the restricted branch. In this branch, it is 1 1 and onto. And again, if you take this branch, again it is 1 1 and onto. So in that way, it is we can restrict the domain to make the function 1, 1 unknown to hence invertible. I am closing this GeoGebra. Dear children, when we are studying inverse trigonometry functions and trigonometry functions, connect everything as far as possible to its graphical view. So it will be permanent in our mind. So from the graph, we have seen that the function f of x is equal to cos x is many one onto, hence not invertible. If you restrict the domain R to any one of the interval minus pi to 0 or 0 to pi or pi to 2 pi or etc., the function become a bijection, hence invertible. So in that branches, it is invertible. This is again graph. We denote the inverse of sine function, just the inverse of cosine function, sorry. So there is a correction. This is a not sine function, it is cos. Inverse of cos function is cos inverse arc cosine. That is another name. And this cos inverse is a function whose domain is minus 1 plus 1 and range could be any of the intervals minus pi to 0, otherwise minus 2 pi to minus pi or 0 to pi, pi to 2 pi and so on. Corresponding to each branch, we get a branch of cos inverse. But the branch with a range 0 to pi is called the principal value branch. The principal value branch. So the principal value branch of cosine function is a closed interval 0 pi. You just think about what is the principal value branch of sine inverse. Principal value branch of sine inverse is minus pi by 2 plus pi by 2. Whereas principal value branch of cos inverse is 0 to pi. Thus, cos inverse from minus 1 to 1 to 0 to pi defined by y is equal to cos inverse of x implies and implied by cos y is equal to x where y element of 0 to pi. This is just the procedure of writing inverse. Actually, cos is from 0 to pi to cos. What is cos? I shall write here. The cos is cos is from cosine function is defined from 0 to pi to minus 1 plus 1. So what will be cos inverse? Here the range become domain of inverse and domain become range of inverse. That is here. Now, some important points. The domain of cos inverse is minus 1, 1 and the range is 0 to pi. They have the result f composition f inverse. Otherwise, f inverse of x is equal to x. So, same way, cos of cos inverse of x is equal to x, where x element of minus 1. Same way, f inverse of f of y will be equal to y. Same way, here, cos inverse of cos y is equal to y, where y element of 0 to pi. These are the important points in the case of cosine function. Now, what will be the graph of arc cos inverse? Arc cos means cos or cos inverse. The graph of arc cos inverse is, you can see that in the part. It is where in the graph, this is the arc cos, otherwise cos inverse. Arc cos, other. I should zoom it here. You can see that this is the graph. This is the graph. So, actually, the domain is minus 1 to plus 1 in the case of cos inverse, and the range is 0 to pi. Now, what will be the graph of cos? I am drawing the graph of cos also here. This is actually the graph of cos, and this is the graph of cos inverse. That nothing, just that. Now, let us think about the inverse of tangent function. Otherwise, we have to define tan inverse. Consider the tangent function f defined by f of x is equal to minus pi by 2 to pi by 2 minus pi by 2 pi by 2 to r given by f of x is equal to tan x. Now, let us discuss the graph of tangent now. So, this is the graph of tangent function. Y is equal to tan x. This is a graph of tangent function. You can see that. Here it is 0, pi by 2, pi, 3 pi by 2, etc. and same way here also. From minus pi by 2 to pi by 2, the tangent function takes values from minus infinity to plus infinity. At pi by 2, it is not touching. At pi by 2, the tangent function is not defined. Now, pi by 2 to 3 pi by 2, again, in this branch, it is from minus infinity to plus infinity. 3 pi by 2, 5 pi by 2, again, it is in the minus infinity to plus infinity, etc. It is going this way. So, if you take the entire real number, actually, tangent function can be defined from R to, I will explain in that slide. Tangent function from R to R is possible. But we have to restrict this domain to minus pi by 2 to plus pi by 2 or pi by 2 to 3 pi by 2 or 3 pi by 2 5 pi by 2 etc. Now, in pi by 2 what happened? The pi by 2, the line x is equal to pi by 2, the line x is equal to pi by 2, the function is not defined. So, the line x is equal to pi by 2 is touching the graph of y is equal to tan x at the point at infinity. So, this line is known as asymptote. We are not studying that in our syllabus, but the line which touches a curve is called asymptote to that curve. So, this is asymptote. Okay, give it. Now, so I have restricted the tangent function in this way, minus pi by 2 to pi by 2. Hence, it is invertible. Here it is, the function is invertible. Now, thus, how to define tan inverse? Thus, tan inverse is from R to minus pi by 2 to pi by 2, defined by y is equal to tan inverse x, implies and implied by tan y is equal to x, where y element of open interval minus pi by 2 plus pi by 2. Please note that the interval is minus pi, open interval minus pi by 2 plus pi by 2. So, range of a tan inverse is open interval. And here also there are some important points. So, domain of tan inverse is set of all the real numbers, and range is minus pi by 2 to plus pi by 2. Open interval minus pi by 2 plus pi by 2. Same way, tan inverse of x is equal to x, where x element of R, the set of real numbers. Tan inverse of tan y is equal to y, where y element of minus pi by 2 to plus pi by 2. So, this is the case of tan inverse. Now, what will be the graph of tan inverse? The graph of arc tangent or tan inverse. The graph of arc tangent or tan inverse. In the x-axis and the y-axis, in the case of tan, will interchange to in the case of tan inverse. So, this is the graph of tan inverse. See, the graph is in this way. Whereas tan inverse graph, tan graph was in this way. In this way is tan graph. Now, this is a tan inverse graph. Now, let us discuss about the inverse of cotangent, otherwise cot. Inverse of cotangent or cot. Consider the cotangent function f defined by f from 0 to pi to r given by f of x is equal to cot x. Actually, I have restricted the domain to some graph. consider the graph of cotangent function. This is the graph of cotangent function. This is the graph of cotangent function. Now, you can see that there are some green dotted lines. See, from 0 to pi, in between 0 to pi, the cotangent takes values, values from minus infinity to plus infinity. Now, pi to 2 pi also it takes minus infinity to plus infinity. 2 pi to 3 pi also it takes minus infinity to plus infinity. And here in this minus pi to 0 also it takes from 0 to minus infinity to plus infinity. So, we are restricting the domain to 0 to pi. When we restrict the domain to 0 to pi, the graph of cot function will be this one. This is the graph of cot function. Now it is invertible. It is both one. It is 1, 1 and on 2. It is invertible. Now we can define the inverse of a cot function here. The cot inverse from R to 0 to pi, the range and domain interchange, defined by y is equal to cot inverse of x implies and implied by cot y is equal to x, where y element of 0 to pi. The important points: domain of cot inverse is R and range is open interval 0 to pi. Now, cot of cot inverse of x, just like f of f inverse of x is x, so the cot of cot inverse of x is equal to x, where x is an element of R. Cot inverse of cot y is equal to y, where y element of 0 to pi. Now, what will be the graph of cot inverse? Arc cot. Graph of cot inverse. You can see here. Here, the graph will be in the different position. That is, x-axis and y-axis will be interchanged. This is the graph of cot inverse. Arc cot. Graph of cot inverse. This one. You want to zoom it. You can see here. So, this is the graph of cot inverse. Now, that's all. Now, we may go to inverse of secant function. Secant. Inverse of secant function. Consider the secant function f defined by f from 0 to pi to minus pi by 2, 0 to pi minus pi by 2. From the closed interval 0 to pi, pi by 2 is removed. To R minus the open interval minus 1 plus 1, given by f of x equal to secant. Of course, we are remembering graph of sine function, cosine function, tangent function. Secant function you may not remember. So, with the help of graph, I shall explain this once again. This is the graph of secant function. See, this is the graph of secant function. It is just like a U-shaped graph. U. Here. Here minus pi by 2, pi by 2, pi by 2, pi, 3 pi by 2, etc. You can zoom it. See, from minus pi by 2 to pi by 2, so all this range, the cosine function, secant function is not taking the values at pi by 2. Here pi by 2 is not taking the values. And 3 pi by 2 also is not taking the values. Okay? So we have to restrict the domain. We are going to restrict the domain in such a way that 0 to pi, I am taking 0 to pi, which point to be excluded, the pi by 2 is excluded. So I am taking restricting the domain to closed interval 0 pi minus the singleton set at pi by 2. That is the function defined in the slide. 0 to pi minus singleton set pi by 2. Now, in that case, the values takes the secant value is taken from minus infinity to it's taken up to minus 1, and 1 to infinity. Secant function is not taking any value between minus 1 and plus 1. So, what will be the range? The range will be entire real line. From the entire real line, the open interval minus 1 plus 1 to be excluded. That is, x should be greater than or equal to 1. Not x, y. Y is greater than or equal to 1 in the case of secant function, and otherwise the y should be less than or equal to minus 1. So the value should be greater than or equal to 1 or less than or equal to minus 1. So the open interval minus 1 and plus 1 is excluded. Is it clear? Let us go back to the definition of secant. That is why the function f is defined as a closed interval 0 pi minus the singleton set pi by 2 to r set of all the real numbers. From the open interval minus 1, 1 is subtracted. So the domain is a closed interval 0 pi minus pi by 2, and the range is r minus open interval minus 1, 1 is defined by f of x is equal to sec x. It is now invertible, and we can define the inverse of sec. The sec inverse is defined in such a way that sec inverse is from minus infinity minus 1 union 1 to infinity to closed interval 0 pi minus pi by 2. Dear children, this is another way of representing r minus open interval minus 1, 1. When we are discussing the graph, we have written that r minus open interval minus 1. It can be the same set r minus 1, 1 can be written as minus infinity to minus 1 union 1 to infinity. Another way of representing the same set is modulus of x greater than or equal to 1. So the set r minus 1, 1 open interval minus 1, 1 can be written in this way: minus infinity to minus 1 union 1 to infinity, or modulus of x greater than or equal to 1. In any way we can write. This is for your information, please. So sec inverse is from minus infinity to minus 1 union 1 to infinity to closed interval 0 pi minus pi by 2. Set pi by 2 is defined by y is equal to sec inverse of x implies and implied by sec y is equal to x. Now y element of the range here. So 0 to pi minus singleton pi by 2. So here also the same points to be remembered. What is the domain of sec inverse? Domain of sec inverse is r minus open interval minus 1, 1. Otherwise we can write as mod x greater than or equal to 1. And range is closed interval 0 pi minus open singleton set pi by 2. Sec of sec inverse of x is equal to x, where x element of r minus open interval minus 1, 1. That is the same set. And sec inverse of sec y is equal to y, where y element of closed interval 0 pi minus singleton set pi by 2. These are all for sec inverse. Now what will be the graph of sec inverse? The graph of sec inverse is this graph. It was partial part of U shape, and here you can see that this is the graph of sec inverse. So graph of sec inverse is this. So 0 to pi minus pi by 2. Pi by 2 is not excluded. when y is equal to pi by 2, the graph line will not touch the graph of sec inverse, so it is asymptotic. And it is taking the value from minus infinity to minus 1, union 1 to infinity. That is the graph of sec inverse. Now, let us move to inverse of cosecant function, cosec function. Consider the cosecant function f defined by f from minus pi by 2, close interval minus pi by 2, minus singletons at 0. This also we have the restricted domain. How we are restricted, that I will show you in the graph. R minus open rule minus 1, 1 given by f of x equal to cosecant x or cosec x. The graph of cosec function is, this is the graph of cosec function. So, you can see that from minus pi by 2 to pi by 2, excluding 0, when we exclude 0, the cosec graph, cosec function take values from minus infinity to minus 1 and 1 to infinity. So, in this interval, minus pi by 2 to plus pi by 2, minus 0, the function is 1, 1 and 1, 2. Otherwise, we can take pi by 2 to 3 pi by 2, excluding pi. Otherwise, 3 pi by 2 to 5 pi by 2, excluding 2 pi. But we are taking the interval, the branch, minus pi by 2 to plus pi by 2, excluding 0. That is the restricted domain. When we restrict a domain, the restricted graph will be this way. So this is the graph of cosec function in the restricted domain. So minus infinity to minus 1 taking values and 1 to infinity. In between minus pi by 2 and plus pi by 2 when we exclude 0. That is defined in the case of cosec function. So cosec function is defined this way. Now we can define the inverse. The inverse of cosec function is a cosec inverse of minus infinity, cosec inverse from minus infinity to minus 1, union 1 to infinity to minus pi by 2 pi by 2 minus singletons at 0 defined by y is equal to cosec inverse of x such that implies and implied by cosec y is equal to x, where y is an element of minus pi by 2 to plus pi by 2 minus singletons at 0. So this is the definition of cosec inverse. Now what is the domain of cosec inverse? Domain of cosec inverse is R minus 1, 1. From the set of real numbers, operand minus 1, 1 is excluded. That is, if the domain is a set of x such that x is less than or equal to minus 1 or x greater than or equal to 1. We can write that domain in another way, modulus of x greater than or equal to 1. So the same domain can also be written. The same domain can also be written as R minus close operand minus 1 can also be written as the same interval can also be written as modulus of x greater than or equal to 1. So domain is R minus operand rule minus 1, 1, otherwise modulus of x greater than or equal to 1, and range is a minus pi by 2 minus singletons at 0. Now cosec of cosec inverse x as f of f inverse of x is x only, where x element of R minus in the domain R minus operand rule minus 1, 1. Cosec inverse of cosec y, f inverse of f of y is y. So cosec inverse of cosec y is y, where y element of minus pi by 2 minus singletons at 0. So we have defined cosec inverse also. What will be the graph of cosec inverse? Graph of cosec inverse is you can see that the graph of cosec inverse. We have seen the graph of cos partial graph, and this is graph of cosec inverse. This is the graph of cosec inverse. Minus pi by 2 to pi by 2 and 0 is excluded here. So, dear children, in this session, we have elaborately discussed sine inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse, defined these inverse trigonometric functions and we have discussed the graph also. Dear children, I am repeating that whenever you are studying trigonometric identities or inverse trigonometric identities or results, try to connect it with its graphical representation also. We will continue the properties of inverse trigonometric functions and other problems in the next section. Thank you.